my name's Jack.
My name is Mason.
And today we'll be talking about the physics of braking. So as you guys know, Newton's first law states that an object in motion will stay in motion unless acted upon by an unbalanced force.
And so, without brakes, your car would just continuously keep moving forever, but obviously there are other forces acting upon the car, so you will stop eventually, but it will take you a while. And so today we'll be talking about two different types of braking systems and demonstrating those braking systems. The first one is a manual brake system, which is on a bicycle, and then the second is a hydraulic braking system, which is on a car.
The logic behind braking is rooted entirely in physics. As we've studied this year, moving objects have kinetic energy. In order to slow these objects down, the kinetic energy of the system must be reduced. We do this through work by friction. Work is given by the equation force of friction times stopping distance. In order to decrease the stopping distance so you don't crash, you need to increase the force of friction. We can do this two ways, either by increasing the weight of the object or by increasing the coefficient of friction. Because we cannot increase the weight while riding the object, we must increase the coefficient of friction. In a mechanical braking system, the coefficient of friction is increased through the use of a caliper system. This system works through using a handle, which then pulls the brake wire, which is connected to the caliper. This squeezes the caliper, causing friction between the wheel and the brake pad. This will now be demonstrated. So the same general concept applies in a car. However, a car uses a hydraulic system for braking.
Which is just a little bit more complex than a manual braking system, in that if your car were to have a manual braking system, you'd probably die.
So before we show you the hydraulic system braking, we need you to write down an equation. This equation is force equals area times pressure.
This equation explains how force is multiplied enough to squeeze the much larger calipers. When you press the brake, you move a small piston that pushes an incompressible fluid, called brake fluid, down a thin pipe. This incompressible fluid is then forced to push up against a much larger piston, which squeezes the brake caliper. Because you are increasing the area upon which the initial pressure was applied, you greatly increase the force. Without this large force, there is no way you could activate the brake calipers, thus increasing the coefficient of friction and stopping the car. So we know that decreasing kinetic energy of the car requires increasing the work done by friction, and we know how the manual and hydraulic braking systems increase this work done by friction, but where does all that energy go?
Well, the law of conservation of energy says that in a closed system, no energy is lost or gained. So therefore, it must go somewhere.
That metal's hot.
Well, the work done by friction caused all that kinetic energy to turn into thermal energy. Therefore, all the metal got hot and you just burnt your hand.
Oh. Now that we know all this cool stuff about friction, forces, work, and hydraulics, let's go out and test it on the road.
Ah! You increased the coefficient of friction way too much!
My bad.